trigonometric functions of some new angles. Here's what I mean. Today, we are going to learn how to find, let's say, the sine of 15 degrees without a calculator. Now, read. Okay, the sine of 15 degrees. We're going to find the sine of 15. At this point, you know how to find the sine of 30, right? The sine of 45 and the sine of 60. Anything that's got a 30, a 45, or a 60 you can do. 15 is not in that list. However, 15 could be rewritten as the difference of 60 and 45. Right? Now, here's how this doesn't work. SIN does not distribute. So you will not do this. This is wrong. It doesn't work that way. Instead, there are some formulas that allow us to find the, let me give myself a little bit more room, that allow us to find the sum and difference of angles, the sine of the sum and difference of angles. So whenever we have a situation where we're going to take the sine of two angles added together or two angles subtracted, and I have the subtraction case here, we'll do an addition in a minute. The formula we use is sine of the first, cosine of the second, and then if we're doing the sum, it's plus sine of the second, cosine of the first. So let's look at that again, because it isn't so much the formula you have to memorize, you just have to understand the pattern that's there. So when we have the sine of two angles added together, we take the sine of the first and the cosine of the second, and then we add the cosine of the first and the sine of the second. If it's a minus situation, we do exactly the same thing, and we subtract. So it will be sine of the first, cosine of the second, minus sine of the second, cosine of the first. Now, what does that mean in terms of this problem? Well, this is your alpha, and this is your beta, right?
Yeah.
So we'll take the sine of the first, cosine of the second, minus sine of the second, cosine of the first. And you can do these two in either order. Sometimes I say sine, cosine, sometimes cosine, sine. Now what do you think you do? Can you find these numbers? Can you find a number here, and a number here, and a number here, and a number here? Can you find those?
Yeah.
Absolutely can. And I would suggest that tonight, when you sit down and do your homework, that maybe over to the side or up in the margin or somewhere, you just go ahead and draw these main angles and just leave them there for reference so you don't have to keep drawing them for every problem, because you're going to keep using the 60s and the 45s and the 30s. So I'm going to draw my 60 here. And I can fill in my 60s then. What's the sine of 60? Root 3 over 2, perfect. What's the cosine of 60?
2.
Not 2. 1/2, right? Adjacent over hypotenuse. And then I'll do my 45. So what's my cosine of 45? Root 2 over 2. And actually, so is the sine, they match. that will be what? Now, these will be multiplied, so what's that going to make? Right here. Root 6 over 4 minus root 2 over 4. Now, those don't really combine, but we normally, since they have a common denominator, we normally write them with the common denominator. But you cannot add these two together. They don't like do anything. It just stays root 6 minus root 2 over 4. And that's it. That's the answer. All right, let's try another one. I want to leave all that, so I'm going to have to erase this. Anybody have an issue with any of this before I erase it? Okay, let's try the sine of, what would be a good one to do? Let's try the sine of 285.
You multiply your base, multiply the bottom. When you add, you have to get the common thing.
Now, to do the sine of 285, we're going to have to break 285 down into two angles. You can only accommodate two. You're going to add two angles together, subtract them. But the angles that you're adding and subtracting have to be 30s, 60s, or 45s. But they don't have to be in quadrant 1. For example, could I have a 60-degree angle in quadrant 2? What angle would that be? 120. So you can use bigger angles. They just have to have a 60 or a 30 or a 45 reference angle. So with that in mind, can you think of, let's do an addition this time. Can you think of two angles added together that would give you 285? Now they have to have reference angles. They have to be at like a 60 or a 45 or a 30. So you want to make a list. What would the 60s be? In quadrant 1 it's 60. In quadrant 2 it's 120. In quadrant 3 it would be 240. And in quadrant 4 it would be 300. 240 and 45 would be an option. Now, gang, do you think there are other options?
Yeah.
Yeah, there are a lot of other options you could use. But this is one option. Would you agree with me?
Yeah.
So what's the formula say? How do I expand the sine of 240 plus 45? Sine 240 cosine 45. Now this is an addition this time, so it's going to be plus
Sine 45 cosine 240.
Is that okay with everybody? So now we got four numbers we got to plug in. Now the 45s are easy. Tell me about the sine and cosine of 45. My picture's still down there. The sine and cosine of 45 is root 2 over 2. Those are the ones that match. You can't get those mixed up. They match. Now 240 is in quadrant 3, and it has that reference angle of 60. That's why we picked it. So this is negative root 3, negative 1, and 2. See how important those negatives are going to be? You have got to remember those. We've been kind of emphasizing that all along. What's the sine of 240?
Negative root 3 over 2.
Negative root 3 over 2. Perfect. What's the cosine of 240? Negative 1/2. So now we multiply. Negative root 6 over 4 minus root 2 over 4. Our answer is negative root 6 minus root 2 over 4. Does that answer look familiar? Sort of. It's kind of like the one we just got, right? Think that's going to happen a lot? Yes. Why?
Because there's a A lot of the same angles.
We're using the same angles over and over again. The only numbers we're using are root 3s over 2s, root 2s over 2s, and 1/2. Think about it, right? 30, 60, 45. So you're always going to get some kind of combination of those numbers if you're doing a sine or cosine problem. Speaking of that, we can do these exact same kinds of problems with tangents and cosines. So I want to give you those formulas now. These are the sine formulas. Luckily, they all come in pairs. So you really only have to learn 3 and then keep the signs straight, the adds and subtracts. Here are your cosine formulas. The cosine of an addition is cosine of the first, cosine of the second, minus sine of the first, sine of the second. So your cosine formula is cosine cosine minus sine sine, or cosine cosine plus sine sine. Now you will notice
They're opposites.
they're opposites. You have a lot to remember. How I keep that straight, I remember that in the sine formulas, the signs are the same. I remember that alliteration, SSS. In the sine formulas, the signs are the same. In the cosine formulas, they're not. In the cosine formulas, they're different. So in the sine formulas, the signs are the same. And then your tangent formulas, you may always, if you choose, do the tangents by doing the sine over the cosine. That will always work. That's what tangent is. There are formulas for these though. Tan plus tan over 1 minus tan tan. There's the formula for the plus, and I'm running out of room. That's the plus formula. The minus is the same thing, but the signs are switched. So your tan alpha minus beta formula is tan minus tan over 1 plus. Okay? All right. Let's just do a tangent problem. They're a little bit different. You approach them the same way, but there's a lot more arithmetic involved. And then I want to do one more kind of problem, and then we'll go over homework if we still have any time. These are in your book, by the way. I wanted to write them down. Your book writes them kind of weird, so I'm going to have them separated for you. Now we're going to do a tangent problem. So let's do the tangent of, how about 165? Now the first thing you have to do is figure out what you can add or subtract to get 165. And remember, whatever you add or subtract has to have a 60, 30, or 45 reference angle. So can you think of anything that would add up or subtract to get 165? 120 and 45. Now that's a great choice. It is not the only choice, gang. So if you are thinking of something else, go for it. Your work will look different, but the final answer will match. There are lots of ways to get 165. This is a great way. This is super. But there are lots of ways to do it. All right, this is a plus, so it's this formula right here. So what's that going to look like when I expand it? Tan 120 plus tan 45 over 1 minus tan 120 tan 45? Everybody okay with that? Now what do you think we have to do? We gotta plug in the numbers here, right? So we gotta figure out, and I erased my 45 down there, but we need to figure out what the tangent of 120 and the tangent of 45 are. So here's 120. What's the reference angle for 120? 60. That's why you could use it, kids. That's why it's such a good choice. Be careful. Isn't the 1 going to be negative? And then here's 45. I had to erase mine. I had it already done. Here we go. We're going to plug in the tangent of 120. What's the tangent of 120? Negative root 3. I'm going to plug in the tangent of 45. What's the tangent of 45? 1. Everybody okay with my plugging in negative root 3 for the tangent of 120 and 1 for the tangent of 1? Or 45, I mean? So I've got negative root 3 plus 1 over 1 plus root 3. Nothing cancels. Do not start canceling things. These plus signs stop you from canceling. What are you going to do with that? You know this. You learned it in second year algebra. The conjugate.
Yeah.
We're going to multiply by the conjugate of the denominator, which is 1 minus root 3. And now we've got a FOIL on the top and the bottom. So here we go. Foiling F O I L over F O I L on the bottom. These aren't hard, but these tangent problems do have arithmetic involved. So what do we have on top there?
Negative 2 root 3 plus 4.
4 minus 2 root 3 or negative 2 root 3 plus 4. Either order doesn't matter. And on the bottom we have negative 2.
Can you simplify?
Can you simplify that? You absolutely can, and you need to. We can cancel a 2 out of everything, right? Actually, I think I'll cancel a negative 2 out of everything. So what will I have left if I cancel a negative 2 out of everything?
Negative 2 plus root 3.
Negative 2 plus root 3, and there's your answer. The trig stopped way back here. All the rest of that's just arithmetic stuff. You okay? So half your homework tonight is problems like that, where you got to take an angle, figure out what you're going to add or subtract, and then use the right formula to do it. The other half of your homework is actually a lot easier. It's stuff that looks like this. They ask you, they give you something like this and say, okay, now simplify that. They don't mean type it in on the calculator. They mean stand back and look at it and say, oh my gosh, I've got sine, cosine, plus cosine, sine. That's a formula. Now today's the first day you've probably ever seen these formulas in your life, so I don't expect you to know it right away. But look at your list that I had on the board. This is a formula for the sine of a sum. Right? Look at the pattern. Sine, cosine, plus cosine, sine. That's what we've got here. That's the formula for the sine of a sum. The sum of what? 17 and 12? So this is a formula for the sine of 29. That's what they want you to do. Just say, what is this a formula for? So here's another example.
Which I kind of like somehow added one and then subtract.
Forget the numbers. Say to yourself, cosine, cosine minus sine, sine. Okay, what is that? That's a formula. Cosine, cosine minus sine, sine is a formula for the cosine. Look at your list. A sum or a difference? Sum. Remember with cosine formulas, they're different. So this is the formula for the cosine of a sum. The sum of what? 99 and 12. So this is a formula for the cosine of 111. That's what they want you to do. You don't type in it. None of this is on the calculator. You're just looking at it and saying, oh, that's one of my formulas. Figuring out which one it is and then simplifying it. Okay, I'll do one more of those and then we'll look at last night's homework questions. How about tan 28 minus tan 11 over 1 plus tan 28 tan 11? It's pretty obvious that's a tangent formula. Tangent, sum, or difference. Look at your list. That's actually that's the tangent of a difference. With the tangent formulas, it matches that sign right there. So this is the tangent of a difference. The difference of what? 28 and 11. So this is the formula for the tangent of 17. Okay, homework's pretty short tonight, those two kinds of problems. Okay, so who had a question about last night's, which wasn't too short, because these were significant problems, most of them. Anybody have one from last night? And remember, you got to pick which ones you wanted to do, so everybody didn't do every problem. Anybody find one we can do here to close out today real quick? 43. Okay, let's look at 43 real quick. This is another classic example of a problem that looks so hard, but it really isn't that bad. If you recognize, Strife, you with me? If you recognize this guy factors. I don't know if when you wrote that down, either last night or just now, when you wrote that down, that you recognized that's like a quadratic, only it's a 4th degree. This is the same as 1 minus 2a squared plus a to the 4th. It's 1 minus 2 times something squared plus something to the 4th. Could you factor this if you found it in the hallway? How would this factor? Wouldn't it factor like that? So how does this factor? This is the same problem, only it doesn't have a's, it has signs.
1 minus
So 1 minus
sine
squared and 1 minus sine squared. Now wait a minute. What's 1 minus sine squared?
cosine squared.
So we got a cosine squared here, a cosine squared here, and the cosine that was in the original problem.
Equal 5.
Cosine squared, cosine squared, cosine gives me my cosine to the 5th. You have to kind of be on the lookout for regular arithmetic stuff, like distributing and factoring and common denominators. Okay? I think, is this the day we stop, is this schedule when we can stop at 8:30? I don't remember either. I think it is 8:30 today because we have mass today. So your homework is in section 5.3. And we'll spend a little bit more time with this tomorrow. I will post your tests
Don't post them.
today.
This is for, never post them.
Actually, pretty fine. I think yours wasn't too bad.
You're good. No, that's probably big.
I know you two apart. Well, of course, I don't know what your aspirations were. Oh, would somebody turn off the video? I don't want to be giving her test score on the
My
video.
aspiration was an F. A D, actually.